Okay, well, we start today lecture. We'll start today lecture about some review for how to design with combinational logics, and after that, how to design the seven-segment decoder, and we will see some design aspect for the combinational logics as well as how to design the decoder with for seven segment, which if you do it with Protos, it's very, I think, good practice that you can learn it better. This is the task for next lecture that I will also inform others that task of seven segments with uh, Protos is for the next one. It's become task number 13. Anyway, um, combinational logic circuit, as we said, that output are function of presence and inputs. We don't have any memory, and it can be described by using the Boolean expression. Please note this that exactly the next chapter, which is sequential circuits, we have some other definition, which is main one is that in that circuits we have something like memory and some feature which has the performance like memory for us. And some hierarchical design is that we can use to solve the large design problem and break the problem into some smaller one is that some problem and solve each sub problem and then combine the individual solution. This is how exactly we are going to design any circuits, especially combinational one. To think for the design concept, we have some specification which is describe the problem for us. First, we should describe it to solve, and after that, we should think that what need to be done and how to do it. And then for the next step that we call it implementation, we will describe how the problem is solved. These are the design concepts. And in that, we have another one, another part that we should think for the issues, means that most solutions are not unique. You saw, for example, for the Carnot map solution, that if you select some loop, maybe your number of gate will be less, or maybe it's become more. It's depend on the skill and experience that you have to select the loops, and also maybe the way that you want to solve the problem by that. Then remember that most of the solution are not unique, and more than one solution may meet the specification. Um, Also, you should identify that cost, speed, power consumption for your gate and design should be proper. Means that you should think for this parameter, and after designing, you should have the optimum or optimization for your design. Then, in brief, if you want to say that what should be the design process, first is that you should identify the requirement, you should list the inputs and need that you need, and then determine the inputs and output. Then for the next part, we are going to draw the truth table, and based on this truth table, we will going to determine the simplified Boolean expression based off suppose Carnot map, and then we go for implementation of solution. Sixth part is that we are going to verify, we will test with truth table that the answer is correct or design is correct or no. This verification maybe some of you in this stage you can use the Pro Tools to do that, and with the help of that simulator you will see that the performance that you have and how it will work. Anyway, that was the design process that we are searching for that. But to have the practice today, there is one hardware element which is very nice and one of the most demand hardware that you will see, I can tell you, anywhere due to its simple um, performance and simple way of use, as well as good cost and visibility and application. This is something that even nowadays some LCDs which are come to picture, but still in cities, in anywhere you will see this parameter. They call it seven segment. But why they call it seven segment? Because it's combination of seven LEDs or seven light. Okay. But they encapsulated or put them together with the with the help of seven LEDs. Anyway, as I say, there is one hardware part which in that they arrange to having the seven number of seven segment, seven number of LED, which they call it seven segment. And by this arrangement, they are going to turn on and off the light. You should know that this arrangement, which has each LED standard for, it's called A, B, C, D, E, F, G, and they put one more LED to showing the dot. Then the combination of turning on the lights with this H shape will create some character and some word. It's limited to suppose showing the W, or there is no difference between U and V to show with seven segment. But anyway, rest of the characters is okay and you can show them. But how you should show means that if you see uh, by this shape of 8, we can turn on suppose L6 and L7. Then if we turn on L6 and L7, we can show the number of 1. Or if you turn on all except turning L2 off, you will see the 0 which will be indicated. Let us see here. Maybe it's shows the 7 segment performance better for you that in that. Suppose for number 0, you will see that all of them except number L2 is on. And if I turn on all, it will shows the number of 8. Suppose if I want to turn on just one, L6 and L7 is on. Or if I want to show the number 2, which LEDs should turn on, and number 3, 4, 5, 6, 7. Then based on this turning on the LED, I can have one table which we show here, and based on these, for any of situation, I can show the number. Suppose if I want to show the value of 0, just L2 should be turned off here. Or if I want to show the number of 6 here, you will see all of them except number L6 is off. See number L6, yes, it's off. You can follow this table and learn how to turn on and off. But really, we are not showing L1, L2, L3. We are label them or put the index of A, B, C, D, E, F, G, and mainly in just showing the number, the DP or dot point is turned off, and then uh, we are not showing that here. That is why we call it 7 segment, because we have 7 LED or 7 lamps. But If you want to see the hardware part, means the real part that we're using in practical or in practice, it has the same shape that I put here for you. And from the just if you want to see it. But from internal side of this seven segment, we have two arrangements. You know, for any LED, we have two parts. One is that anode, one is cathode. And from anode to cathode, we have the movement of current through this LED. Means that if you want to turn it on and off. If I connect all these parts, cathode part as the common part together, I can say that I have common cathode one. And if we connect the other side, means that the anode part together, we will connect the common anode part. The difference between these two type of display is that common cathode one has all the cathode of that connect directly together, and in common anode, all the anodes are connected together. Means that the common part is different, something like that. See, here we are connect all the cathodes for the LED, and here we are connect all the anode parts for the LED part. Then you will see that we have two different uh, type of seven segment, which we call it common cathode and common anode part. Then, as the abbreviation, they are showing CCD as the common cathode display, which in that, if you give the one um, to individual part of this and just connect in the common pin to the ground and take one, all the LED turn on. And for common anode part, if you give um, the logic one individual to the segments, and then the common part you make it zero, then the uh, seven segment will turn on. Then please remember that the difference between these two hardware parts will indicate for us how we should turn on and how we should turn off the um, seven segment. Anyway, as in this figure I show mm, uh, here, all the anode segments are connected together. And when we are working with common anode seven segment, power must be applied externally to the anode connection that is common to all segments. And then by applying the ground to particular segment connection, means that A to G as it's shown in the figure, the appropriate segments will be turned light up, and additional resistor also we will add to the circuits to limit the amount of currents for our LED segment. Means that along with this hardware, means that just LED, we need some resistor real life to protect and limit the current which these LEDs need. These LEDs work. I show the common anode seven segment here. As you see, the anode part of my LEDs are connected together, which in my real seven segment also, that pin is specified for the hardware. And you will see that by giving the voltage to any of the seven segments, they become turned on. Okay. For common cathode seven segments, also as you see, uh, which is the difference between common anode one, is that cathode of all LEDs are connected together, and for the use of these seven segments, The common cathode connection must be ground, and then power must be applied to the appropriate segments in order to eliminate the uh, segments and make it on. Here I shows that how we should connect one or just one digits of 7 segments to the parts that we call it decoder. Then what is the aim of decoder? Aim of decoder is that we can send the um, codes to our 7 segments, and then by that we can um, turn the 7 segment turn the 7 segments on and make it on and off. Then we need some decoder to uh, help us to put the codes on 7 segments. And then one of the famous one is 7511, which it's BCD to 7 segments display driver. And by the help of that, we can um, run our 7 segment. Between this decoder and 7 segment, as you see, we are using some resistor. Generally, they will use 750 ohms or 390 ohms. 7 of them we are using because we have really 7 LED or 7 lamp. And by giving the command to this BCD decoder, we can turn on off. Now we want to know which command and how we should send the signal to this 7 segment BCD decoder to run the LED. See here, the whole block diagram will be like that. Means that the common part will connect to the ground with the help of one resistor, and then all segment of my 7 segments will connect to the decoder, and then before decoder I have some switch. As you see, this is 4 to 7, 4 key I have, and then by putting the BCD inputs here, then I can turn uh, the LEDs on. Suppose here, if I send the codes of 0100 as the BCD inputs, I should know, I should have the codes of 4 on my 7 segments here. Okay, it means that now the input one is my BCD, and my output is the number that I want to see exactly on the 7 segment part. Um, then for the 7 segment decoder, we have some circuit specification which the decoder must decode the binary code, decimal, or BCD digits so that they can be displayed on our 7 segment one. And we should determine the inputs and output output. The inputs for us is binary coded decimal digits, and we can assign the 4 bits to each decimal digit. Suppose a 4-bit code, then we receive us, and they are only 10 digits in our digital or in our decimal number system. Something which should be noted for you that unsigned scores are not used. And how do we interpret this um, unused code is needs some trick, which with the help of Kmap you can do that. Now don't think for that part, just think for showing the numbers on 7 segment. Here I show you them. Last time in last lecture we saw suppose in BCD we just have the number of 0 to 9. Okay, and here this is the BCD codes which represent in table, and you can see the decimal digits on that. Uh, Here again, now you have some information about 7 segment. Now you can see that how we turn on and on. Try to put it in these four. In that you can see the BCD code as well as the number which shows on um, 7 segment. Suppose you see the 0, this is 7, 8, 9. I show down. Then you will see that character E I can show like this, F I can show. Then rest of them I cannot again show. Suppose G I cannot. Maybe G I can show, but it's not much more visible. You will see that I have some limitation to show the 7 segment character and show the performance of that. Uh, Again, here I try to show the 7 segment, but with the help of the character uh, and also BCD codes that related to that. Suppose if I want to show the 0, the truth table is like that. A, B, C, D, except G should turn on. Then 1, 2, 3 till 9. That we are practiced that before. Remember this, and it's not difficult. Just know the sequence of A, B, C, D, E, F, and G, and then based on these characters and this turning on the lamp, you will learn how to show the number on your 7 segment. Okay, this is also again one more truth table, which based on now this truth table, we can design the circuits who do the decoding job for us and shows the number on our part. Um, from 0 to 9 and A to F. Yeah. How I should show for any of these parameter, means that for parameter A, I should draw a specific or individual value, and how I should show very simple. Suppose for A, parameter of A, I just put the marks or the part that in that A parameter is on. Okay. B, same logic number B. What about D part? With help of that, we should work till number 7 of Carnival. What I have done here, I bring the 7 segment display for you, uh, and then showing the suppose for number A, if I want to show the the mean term for the 89. So I showed the mean term part. And again, um, I put all of them together and then design the or simplify the last simplify the last Boolean expression, which represent the A, B, C, D, E, F, G. I want that you do this individually and independent. Just looking at my PPT independently, please see it and try to solve and simplify. And then after that, you can draw the 7 segment design. This is your task. Means the next task is that you should draw it with hand. Okay. Now this time I don't want any file, any Word file. You should do it with uh, hand and send the picture of that for me. First you should draw the true table. After that put it in the kernel map and then simplify it. It's okay for today.